Alright guys, today we are going to start imaginary numbers. Oh my goodness, right? Imaginary numbers. So looking at our notes for today, imaginary numbers, right here. It says equations such as x squared plus 1 equals 0 have no real solutions. Okay, so mathematicians define the imaginary numbers to represent their solutions. An imaginary unit, which we call I, is defined as the square root of 1. This is useful when working with square roots and negative numbers. A pure imaginary number is written in the form bi, where b is the real number and obviously I is the imaginary part. So if you look here where it says simplify negative square roots, we can rewrite the negative square root of a, right? Because you can't take the square root of a negative number, but we can rewrite this as the square root of negative 1 times whatever a is, times whatever number that is. Now, once you break it up, we can break down a by its factors. Okay, and then we can simplify the radical because we know that I is equal to the square root of 1. Okay, so let's look at what that looks like, right? The square root of 9. I could rewrite this as negative 1 times 9. Okay, well we know that negative 1 is I, right? So we have I, and now we're going to break down the square root of 9 into factors of 3 and 3. So I have a pair of 3's. They come outside the radical. So outside the radical, I have 3i. Let's look at the square root of 196. Okay, the square root of 196, again, the square root of negative 196. Again, we're going to take this and we're going to say this is the square root of negative 1 times 196. Well, we know that negative 1 is I. We break down 196, we can break it down into 2 and 98. 98 is also divisible by 2, so we can break that down into 2 and 49. And 49 is a perfect square. So I have a factors of 7 and factors of 2 that come outside. 7 times 2 is 14. I. Alright, let's look at number 4. Okay, number 4, I can break this down as negative 1 times 80. Again, 8 breaks down into 8 and 10. Okay, so no factors there, so I keep going. This breaks down into 4 and 2. That breaks down into 2 and 5. So now I have a factor that comes outside of the radical. This square root of 4 is a perfect square. That also comes outside the radical. So we have 2. We have another 2. So we have 4 outside the radical. We have I. And then underneath we still have the square root of 5. Alright, let's look at solving equations, right? So now we're going to solve our equations. What we just talked about up here, okay, we have imaginary numbers as solutions for our quadratics. So looking at number 7, I want to solve for x. So the first step is to subtract 81 on both sides. So we get x squared equals negative 81. So I want to solve for x. I'm going to take the square root, which means x is equal to the square root of negative 81. Now, once again, you know you can't take the square root of a negative number. But we can break this down and say this is the negative 1 times 81. Well, 81 breaks down into 9 and 9. So that comes outside the radical. So my answer is x equals 9i. Alright, that's plus or minus 9i. Okay, holy smokes, that was almost bad. Alright, let's look at number 9. We want to subtract 9 on both sides. We get negative 8 is equal to 2x squared. Divide by 2. X squared equals negative 4. Take the square root, so we have the square root, x is equal to the square root of negative 4. Again, we know that breaks down into 2 and 2. We know this becomes I. So x is equal to plus or minus 2i. Easy breezy, right? Alright, put the paper up. So we have powers of I, and we can recall a pattern from these powers of I. Right? So I raised to the first power is going to be equal to the square root of negative 1. I raised to the second power is equal to negative 1. Why is that the case? Because we have negative 1 times negative 1. Because I squared means that we have it times itself. So let me focus this. I squared means we have it times itself, right? So I have negative 1 and I have another negative 1. So negative 1 times negative 1, the square root of negative 1, times the square root of negative 1. Square roots cancel out. We're left with negative 1. I cubed then is going to be negative 1 and then another square root of negative 1. Because we could say I cubed is I squared times another I. Well, we know that I raised to the first power is the square root of 1, negative 1. And we know that I squared is negative 1. Bam, that's where I got that from. So then I to the fourth is again I squared and another I squared. Well, I squared is negative 1 and another I squared is negative 1. So negative 1 times negative 1 is positive 1. This is going to be negative square root of negative 1. I don't have to write the 1 in front. This is going to be is equal to negative 1 because this is negative, the square root of negative 1 times the square root of negative 1. And then I raised to the first is the square root of negative 1. So in dealing with this pattern, I can say that I to the fifth is I times I to the fourth. Well, I know that I is the square root of negative 1. I know that I to the fourth we just said is a positive 1. So that's going to give me the square root of negative 1. I to the sixth, again, is I times I to the fifth. Well, we know I to the fifth is a negative square root of negative 1. We know I to the first is a square root of negative 1. So again, I multiplied two of the same square roots. They cancel out. I'm left with what's underneath the square root. I to the seventh, again, right here, negative 1 times the square root of negative 1. And I get negative the square root of negative 1. And then, obviously, this is going to be positive 1. So you can see my pattern here. I have these four answers in patterns of 4. Right? So I to the 15th, I can say that is going to be I times I to the 14th. Okay, well I can break this 14 down and say 14 is a pattern of 2, right? I'm looking for, pattern of 4, excuse me. So if I break this down into a pattern of 4, 4 times 3 is 12, right? So I know that I have 2 left over. So I'm going to say I times I to the 12th, I to the second, right? 12, 2, and 1. All right, so I raised to the first is going to give me a negative square root of negative 1, excuse me. I to the 12th is a power of 4. So I know I have 1. And I squared, we know, is square root of, negative 1. So the answer here is negative 1 times positive 1, which is negative 1, times the square root of negative 1. So negative square root of negative 1. Yeesh. Yeesh. All right, let's look at products of imaginary numbers, right? So products of imaginary numbers. All right, so all we're doing is we're going to multiply the numbers, okay, and then we're going to multiply the i's. So 4 times 7 is going to give me 28, I squared. Okay, well, what is I squared? We know that I squared is negative 1. So this is going to be equal to negative 28, or negative 1 times 28. Same thing here on number 17, right? I have 2i raised to the third power. So I have 2 raised to the third. I have I raised to the third times, okay, or I'll put it in parentheses, 5i. 2 raised to the third power is going to give me 8. 8 times 5 is 40. I raised to the third, I raised to the first, that's I to the fourth power. We know that I to the fourth power is 1. So 40 times 1 is 40. Let's do another one like that. So let's look at number 18. I have I squared. And I have square root of 3, square root of 3 squared, which gives me a positive 3. Times negative 8 squared, which gives me a positive 64, and I squared. All right, so now I've got 64 times 3. Holy smokes, I don't know that in my head. Sorry, let me do 64 times 3, 192. Yeesh. I need to do some math. All right, and then I've got I squared times I squared, which again is I to the 4th power. I to the 4th power we know is positive 1. It's a multiple of 4, so 192. What about when I'm multiplying radicals? Okay, well, nothing changes. Let's look at number 20. Right, I'm going to multiply 24 times 3 times 2. So 24 times 3, which gives 24 times 3, which gives me 72, and then times another 2, which gives me 144. So I've got the square root of a negative 144, because the negative times the positive times the negative is a negative. All right, now I can break this down and say this is negative 1 times 144. Well, I know that 144 is a perfect square, 12 and 12, bop. Okay, this negative 1 is my I. So that comes outside, the I is right there, 12I. I like it when math is simple.